Hello guys, today we are going to see another daily lead code problem 1930, which is unit length 3 palindromic subsequence problem, right? So let's understand the problem first. So what it is saying over here is like we are given a string yes, right? And we have to return the number of unique palindromes of length 3 that are a subsequence of yes, right? And also we all know what is a palindrome, right? And we also know what is a subsequence. So if you don't know what is a subsequence, so let's understand what is a subsequence. So let's take this example itself and let's come back to our notebook to see how we understand subsequence. So suppose in our example it was given like a b c d e, right? So what we can say is like b d e is a subsequence of the string a b c d e. Also, there is one thing known as substring. So substring can be something like the consecutive occurrence. So like C D is a substring, but A C and D, A C D is not a substring. It is a subsequence. Subsequence is generally in a sequence, but within that string itself. So I hope you have understood what is a subsequence. So, anyways, let's see what we are trying to do. So given let's see what the example here we have given A B C A B C A, and the output is 3. So what we are doing is like we are calculating the palindrome subsequence of length 3. So here if you see the subsequence ABA, which is like A and then this A and then this B and then this A is a subsequence. Similarly this A, this A and this the next A, and then again this A is also subsequence of length 3 and they are palindrome, right? Because from backside also if you see it's A on itself. Similarly this A and then this C and then this A, this can also form a palindrome. So let's understand the intuition of solving this problem. So let's take a kind of little bit complex example and understand how do we solve this. So our example can be something like B, B, C, B, A, B, A. So if you see what is the number of palindromes of length 3. So someone can see says like B, this B, and this B can be one palindrome, of course. Similarly, this B can be another palindrome. But again, see both are same. So we have to count only one that is given in the question. Read it carefully. So we cannot consider this part. Again, what we can consider is like B, C, B can be one palindrome, right? So this B, this C, and this B can be one. Again, this B, this C, this B cannot be another because again it's same and repeating. Again, another can be B, A, B, right? And then we have A, B, A. So I think that's all. We can only form these 4 palindromes, right? And not this one. Yeah. So to do this, we can do something like we can create you know what we call we can create something known as the position like so suppose we do something like this. We iterate through each and every character and we see left of it and right of it, and if we have the same character that can form one palindrome, right? So for example, if we see this C, let's say this C, we are at this point, and suppose if we see at the left we have a B, right? At the right we also have B. Yeah, then this C can contribute to form one such palindrome which we are looking for. If you see this B, this can contribute to form because in its left there is a B, in its right there is a B, right? But if you see something like this A, so this for this A there is this B and this B. Yeah, this can help to form one palindrome, but not any other thing can help over here. If you see for this B, this A and this A can help to form palindrome, right? So A B A can be one sequence. So in this sequence we have to see how to form the palindrome. So what we'll do is like we'll calculate the first occurrence of a character. So we have 26 characters, right? And in the question we are given that we can only use small case alphabets, so data 26 from small a to small g, right? So let's say we will basically create a vector. So given a string yes, we are given with a string yes, right? What we do is like we will create a vector integer, right? And we say is like first occurrence of certain characters. Let's say like we'll create a vector where we store the first occurrence of the character. Like there are 26 characters, right? So for the all the 26 character we'll initialize this with say int max. Similarly we'll create another vector which will store the last occurrence, right? For 26 last occurrence, and we'll say it contains -1. Yeah, like it does not contain any character, right? So what we do is like we will traverse through this string which say b b c b a b a, right? We will traverse through this string and we will store the first occurrence and last occurrence, first and last. So see, the first occurrence of b is at position 0, right? Like we are traversing in its last occurrence as of now is 0, because we have not seen these parts, we have just seen b. Now we come to this b, its first occurrence is already we already have. So what we can do in this case is like we will see the minimum of already stored, right? Stored and the current position, whichever is minimum we will store in the first, and for the last we will store the maximum of the store and the current position. So we'll update this last position by 1. Now we again iterate, we go to c, right? So for c the first position will be, so this is for b, like okay, how do I, yeah, well, let's create a array kind of thing, yeah. So this is for example for a, for b, for c, for d, everything. This is the first one. Similarly for last one we'll create another vector where a b c d all are the indexes, right? And this is the last occurrence where we are storing. So for b basically we have stored first occurrence as 0, and for b the last occurrence was 1 as of now, right? So now we are at c, and when we see look at c, for c the first occurrence is 0 1 2 3 4 5 6. So for c the first occurrence is c and last occurrence is c as well, right? Again we'll see b, and the last occurrence will change from 1 to 3, right? Again a, the first occurrence will be at 4, last occurrence will be still at 4. For b, last occurrence will change to 5, right? Again we'll see for a, first occurrence is 2, it's like 4 itself, but the last occurrence is at position 6 c, right? Now we have the first occurrence and last occurrence of each and every character. So we iterate through all these 26 characters, and whichever characters which are present in our, this first occurrence and last occurrence vector, what we do is now finally, so we'll for a the first occurrence is 4 and last occurrence is 6. So there how many unique characters are in between 4 and 6? So from 4 and 6 in this string, we'll see how many unique characters are there, and we'll find that okay, there is only one unique character. So this a will like this part will contribute for one, one palindromic six subsequence of size 3. Similarly we'll go to b, the first occurrence is at 0 and the last occurrence is at 5. So between 0 and 5 how many characters are there which are unique? So see, b is not unique, right? So like b is unique as of now, c, a, 3 are unique, right? b, c and a, between this and this, right? So we'll add 3 for this. We'll go to c. For c, first and last is 2 and 2 itself, right? So there is no any character, so it's 0. C is contributing 0. Similarly for d, there is no d, 0. E, F, everything will do. So till Z, if we do, we'll get 3 plus 1, 4, which is our answer. So now let's see the code. Yeah. So over here, you can see this is the count palindromic subsequence string, right? length, we have calculated the length, and then we have initialized the vector where we have the first position occurrence and the last position occurrence. And then what we are doing is like, let me zoom out for you. Yeah. So we'll traverse the string to find the proper position. That is the first occurrence and last occurrence, right? So we'll traverse through the string, yes, like from I0 to the length, and then what we are doing is like we're extracting that character position, right? And then we are in the first occurrence position of that characters. Let's say for B, we are storing the minimum of the value and the current position, whichever is minimum we are storing. And again for last position we are, so in using this loop we are creating our positions, first and last positions, right? And then we'll create a variable, let's say answer, to initialize our answer to 0 as of now, so that we'll update the answer later. And then what we are doing is like we are traversing from each and every character, like from A to Z, right? 0 represents A and 25 represents Z, right? And what we are checking is like, if the first position of certain character, let's say A, is length or it's -1, the last character is -1, it means that we have not seen that character, right? So we'll just continue, we'll not this, because this is not going to contribute anything in our answer, right? We'll do that. And we create an unordered set of characters to store the unique characters, right? To store unique characters in between the first and last. So now we have that character, we have, suppose we have A as of now, and what we are seeing is like the first occurrence of A, that position, and then till the last occurrence of B, we are adding all the characters into the set, right? And we at the end we'll have unique count, like unique, there will be unique characters inside the set at the end. So we are adding the size of this set, and then again loop will run, and then we'll again initialize this set, and we'll check for character, and from A to Z we'll increase the count and we'll store in this. And let's submit this code. Yes, so yeah, it is working perfectly. And for you, I'll just minimize so that you can see the entire code at once for your references. I hope you will be able to see the entire code. Let me do so, yeah, and then zoom it a little bit for you. Yeah, I hope you can understand this. Thank you.